Okay, think about all the ways you group things in your life. Your music playlists, your different groups of friends, even your work projects. Well, today we're going to dive into a super powerful math tool called Cardinality. And it's all about counting and understanding these groups in a way that's incredibly precise.
But you've hit this problem before, right? What happens when those groups overlap? You've got friends who are also coworkers, or maybe a song that's on both your workout and your focus playlist. How in the world do you count the total number of people or songs without counting some of them twice? Well, that's the exact puzzle we're going to solve right here.
So, to tackle that whole double counting issue, we need to get a little more formal. Let's start with the basics of how we count items within these groups, which, in the math world, we call sets.
And that leads us right to our big deal term for today, cardinality. I know it sounds super formal and maybe a little intimidating, but trust me, it's not. All cardinality means is the number of things in a group, or a set. So if you've got a set of 5 apples, its cardinality is 5. It's literally just a fancy math word for how many.
All right, so these sets can relate to each other in 2 really important ways, and getting this difference is absolutely crucial if we want to count them correctly. Let's dig into what makes sets either overlapping or what we call disjoint.
So disjoint sets are just completely separate, no connection whatsoever. Think of it like cats and dogs. An animal is either a cat or a dog. It can't be both. But overlapping sets, now they share at least one thing. Think about people who speak Spanish and people who speak French. You'll definitely find some people who can speak both.
The easiest way to picture this is with a Venn diagram. For disjoint sets, the picture couldn't be simpler. You've got 2 circles that don't even touch. They're in the same universe, sure, but they have 0 shared space.
But for overlapping sets, that picture changes. The circles cross over each other, and that creates this shared area in the middle. And that little shared space, that's everything. It represents all the items that belong to both sets at the same time. And this, right here, is where our counting problem began.
Okay, now that we see the difference, we can finally introduce the master formula. This is the tool that lets us accurately count everything across 2 overlapping sets. Honestly, this is the real heart of what we're learning today.
And here it is. The total number of items in the union of A and B, that just means everything that's in A or in B or in both, is the number of things in A plus the number of things in B minus the number of things in their intersection. And that intersection is just the name for that shared overlapping bit.
So you might be asking, wait, why are we subtracting? And that is the absolute key to this whole thing. See, when you just add up all the stuff in set A and all the stuff in set B, you've accidentally counted everything in that shared middle part twice. It got counted with A, and then it got counted again with B. So by subtracting that shared part, the intersection, just one time, we fix that double count. Boom, problem solved.
And this makes perfect sense when you think about it. For those disjoint sets, the ones that don't overlap at all, what's their intersection? It's 0, right? They don't share anything. So that last part of the formula, the minus part, just becomes minus 0. So it simplifies perfectly to just adding the 2 sets together. The math works beautifully for both situations. Now let's get into a really interesting, special kind of overlap, the subset. This is what happens when one set is completely, 100% contained inside of another one. So let's make this real with an example. Let's say we have a set A, and its cardinality is 65. Then we have set B with a cardinality of 80. And the key piece of information is this. Set A is a subset of set B. Our mission is to figure out everything we can about how these 2 sets relate to each other. So what exactly do we mean by subset? It's simple, really. It just means that every single thing that's in set A is also inside set B. Visually, it's not just 2 circles overlapping. It's one circle drawn completely inside the other one. A good way to think about it is that poodles are a subset of dogs. Every single poodle is also a dog. Okay, we've got all the concepts and the formula. Let's put our knowledge to the test and just walk through the solution to this problem, step by step.
We're going to use a clear 4-step plan. First, we're really going to think about what A is a subset of B actually implies. Then we'll calculate their union, their intersection, and finally, we'll figure out the differences between them.
Okay, this first step is the big aha moment. Seriously, just think about it. If set A is completely inside set B, what do they have in common? What do they share? Well, they share all of A, right? The entire set. So their intersection is just A. And what happens when you combine them? You don't get anything new, you just get the bigger set, B. So their union is B.
Just getting these two simple facts straight basically solves the entire problem for us.
First up, the union. Remember our shortcut? Since A is totally inside B, combining them just leaves you with the bigger set, B. So the cardinality of their union is just the cardinality of B, which is 80. Easy. Next, the intersection. What's the part they share? Well, again, since A is living entirely inside of B, the part they have in common is all of A. So the cardinality of their intersection is simply the cardinality of A, 65.
All right, now for the differences. What's in A that is not also in B? Well, think about it. Since every single element of A is already inside B by definition, there's nothing. There's nothing left over. The answer here is 0.
And for our last calculation, what's in B that is not in A? This is good stuff. We take the total number of items in B, which is 80, and we subtract the part that's also A, which we know is 65. 80 minus 65 leaves us with 15. So there are 15 things that belong only to B.
And that's it. You've got the toolkit. From your friends who are also coworkers to your songs that show up on multiple playlists, the logic of cardinality and sets gives you this incredibly powerful way to organize your world and avoid double counting. So the real question is, now that you know how it works, what parts of your world can you finally organize and count with perfect clarity?